So let's move ahead with our .NET Fundamental Q&A series, and let's start with the next question. What are three kinds of JIT and what is NGEN.exe? Now, in our previous video, we have looked into what is IL code, CLR, CTS, JIT, etc. Now, in this session, what we'll do is we'll dig further into JIT and we will know more about JIT. Now, as said in the previous session, that JIT is nothing but a .NET compiler which reads your IL code and translates the same into machine-specific instructions. Now, in this session, what we'll do is we'll look into three kinds of JIT, and we'll also look into something called as NGEN.exe, which helps us to compile the whole .NET code in one go, rather than compiling each line of IL code and then convert the same into machine-specific instruction. So what we'll do is we'll first try to understand what are the three different kind of JIT, and then we'll do a sample demo of NGEN.exe to understand how it helps us to implement full compilation in one go, rather than doing step by step on the fly. Primarily, there are three kinds of JIT: normal JIT, econo JIT, and pre-JIT. Now, the normal JIT is the default implementation. So when you compile your exe or your DLL and when you execute them, it uses the normal JIT. Now, in normal JIT, only those IL code or those lines of IL code are compiled to machine instruction, which are needed during runtime. So in other words, any IL code which is not needed during runtime will not be compiled by normal JIT. Now, this compiled IL code is then cached. Now, please note that this cache is a in-memory cache. So in other words, the cache will be erased, once you close the application. Now, the second kind of compiler or JIT compiler is econo JIT. Now, econo JIT is again very much similar to normal JIT. In other words, it compiles only those code, which are needed during the runtime. But it has two big differences. One is that it does not do any kind of caching. And second is, it just replaces the IL code with native counterpart. In normal JIT, what happens is it does not just do the replacement, but what it does is it looks into the environment. It sees that what is the most optimized code, which can be produced for that environment. So there are two big differences between econo JIT and normal JIT. The first is that econo JIT does not do any kind of caching, and second is that econo JIT, just replaces the IL code, while normal JIT actually, replaces the IL code with optimized code. Now, so what's the use of econo JIT? As said, that econo JIT does not store the compile code into cache, so it requires less memory. So in other words, econo JIT is chosen, when devices have limitations of memory and CPU cycles. For example, like your Windows CE powered device. So when there is no memory crunch or there is no CPU power issues, then you can use normal JIT. But especially for mobile devices and Windows CE devices, probably econo JIT is the most viable one. Now remember that the choice of normal JIT and econo JIT is all decided internally. So in other words, when you go and create a Windows CE project, right, it will ensure that the compilation is done using econo JIT. And when you create a ASP.NET or a Windows application, it will use the normal JIT. Now the third kind of compiler is a pre-JIT. Now pre-JIT, what happens in pre-JIT is that it compiles a whole source code into native code or into the machine specific instruction. So as compared to normal JIT and econo JIT, where the only those IL code are compiled which are actually needed during execution. In pre-JIT, the whole IL code is compiled into native code in one go. So during the deployment itself, the code is completely in machine specific instruction. Now, in order to implement pre-JIT, we need to use something called as NGEN.exe. So what we'll do in the further videos is we'll see that how NGEN.exe helps us to deploy the complete the complete IL code into native code in one go, and we'll also see that how it helps us to increase performance. Now, in order to demonstrate pre-JIT by using NGEN.exe, what I've done is I've written a simple function here called as get prime array by max. So this function basically helps us to calculate prime numbers. So you basically give him the maximum prime number, and it will basically calculate prime numbers using using a logic. Now what we're going to do is basically this function, we are going to call in a Windows form here. So you can see that basically I have a simple Windows form here. It's there is nothing on this form as such. On the form load, what I'm doing is I'm just calling up the prime number function. Okay. And what I've done is I've used the stopwatch to basically measure that how much time does it take to execute this prime number function. And what I'll do is I'll compile this program. I'll first run this program normally. So in other words, it will be using your normal JIT, and then basically I will use NGEN.exe to basically compile it by using pre-JIT, and then we will see that how much time does it take. So basically just let's run this code and let's compile it in a release mode. And what I've done is, as already said, that basically I have used a stopwatch. So I've started the stopwatch before this function starts, and then I'm basically stopping the watch, and then I'm saying that, okay, how much milliseconds did it take to execute this function? So we have compiled it, and now what we'll do is, let's go ahead and run this function, and let's see that how much, or let's run this program and how much time does it take. So you can see that basically it has taken 16 milliseconds. So let me just make an entry of 16 milliseconds. So let me just open a notepad here, and 16 milliseconds with normal JIT. Now let's go ahead and basically use NGEN.exe to make this a pre-JIT, compile this using pre-JIT. Now in order to use NGEN.exe, or in order to pre-compile your, compile your program of .NET using pre-JIT, what you need to do is, you need to go to your Visual Studio command prompt and say NGEN.exe and give the whole path of the exe where it is currently. So currently my exe is lying on my release folder here, and I've gone to the Visual Studio command prompt and I'm saying NGEN, please go ahead and basically, compile this whole exe into machine specific instruction and keep it in your cache. So let me just run this, and you can see that it has successfully executed, or successfully basically compiled this whole IL code into machine specific instruction and stored into cache. Now let's go and run the program, and let's see that if you are getting any kind of performance difference. You can see that it has only taken 13 milliseconds as compared to our previous normal JIT, which took 16 milliseconds. So 13 milliseconds for pre-JIT. Now it's very much possible that you'll go and update your application, you will write some logic, you will compile it, you recompile it, etc. So you would like to sync up your NGEN cache with whatever you have changed. So in other words, you would like to basically go ahead and remove the NGEN current cache and basically again update the fresh compiled exe or the DLL in the NGEN cache. In order to remove the current DLL or exe from the NGEN cache, what you can do is you can use NGEN/delete and then NGEN testing. So that ensures that this exe or the DLL is removed from the NGEN cache. And you can again go ahead and basically just install it again, and it will go and update your current code with the cache. Now many times you would like to also go and basically see that basically go and find that basically is the specific exe or the DLL present in the NGEN cache. So you can use NGEN display and say NGEN testing. That's my assembly name. So you can see that it says, okay, that this guy is installed. Okay. If you want to further investigate and see what are the other commands of NGEN, what you can do is you can just run NGEN, and you will see that there are various other things you can do, like uninstall, update, display, queuing, etc. Now said and done that, do not get carried away with my demo. Means do not conclude that NGEN.exe will always increase performance. Remember that NGEN.exe does not produce the optimized code. Why? Because wherever you have ran an NGEN.exe, it uses the current environmental parameters. And if these environmental parameters they change over a period of time, then the code what has been compiled by NGEN.exe is not the optimized code for that environment. If you see in normal JIT, what happens is it compiles the IL code on runtime. In other words, whatever IL code is needed, it compiles on runtime, and it basically checks that what kind of environmental parameters are currently present and produces optimized code accordingly. So NGEN.exe does not produce optimized code. So in other words, before even concluding that NGEN.exe will always increase performance, you need to first test the same on your application and ensure that your NGEN.exe basically increases performance. So do not conclude that NGEN.exe increases performance. Do a test once and then basically see that how it is suitable for your application. Now there are two big other problems with NGEN.exe. The first problem is of synchronization. Now what happens is whenever you update your exe or whenever you update your DLL, you also need to go and update the NGEN cache. That's the first problem. The second problem is, let's say that you have 15 or 20 machines, where you have to go and install your exe, then you have to go and run the NGEN.exe in each of these machines. So basically a choice of NGEN.exe should be done with a proper POC to see that, if it really increases the performance, because with NGEN.exe, you come with extra burden of deployment as well as, of synchronization. So I hope that this session was useful, and in this session what we did is we basically saw the different kind of JIT, and then we saw how NGEN.exe can help us to increase performance. So be tuned with the fundamental video series, and I hope that you will benefit from this whole video series. Thanks a lot.